Category 3 marine diesel engines typically range in size from 2,500 to 70,000 kW, 3,000 to 100,000 HP. These are very large marine diesel engines used for propulsion power on ocean-going vessels such as container ships, oil tankers, bulk carriers, and cruise ships. Their high power output and efficiency are essential for propelling these enormous vessels across the world's oceans. Manufacturing marine engines is a complex process that involves several steps, from design and casting to assembly and testing. Here's an overview of the typical process. The process starts with the design and engineering of the marine engine. This includes determining the engine's specifications, power output, fuel efficiency, and other performance parameters. Engineers create detailed 2D and 3D CAD models of the engine, including all its components. High-quality materials are selected for various engine components, including the engine block, cylinder heads, pistons, crankshafts, and more. These materials are often chosen for their strength, heat resistance, and corrosion resistance. Engine components like the engine block and cylinder heads are typically cast from materials like cast iron or aluminum. Some critical components may also be forged for added strength. Casting and forging processes involve melting the chosen material and pouring it into molds to create the desired shapes. After casting and forging, components go through extensive machining processes to achieve precise dimensions and surface finishes. CNC, computer numerical control. Machines are often used to ensure high accuracy in machining. The various engine components, such as the cylinder block, pistons, crankshaft, camshaft, and other parts, are assembled together. Precision is crucial to ensure the engine functions properly. Throughout the manufacturing process, quality control checks are conducted to identify and rectify any defects or deviations from specifications. Inspection includes dimensional checks, material composition analysis, and non-destructive testing, e.g., ultrasound and X-rays. Engines are often painted or coated to protect against corrosion and enhance their appearance. Various accessories, such as the cooling system, exhaust system, and electrical components, are integrated into the engine during the assembly process. Completed engines undergo rigorous testing to ensure they meet performance and safety standards. This includes running the engine at different loads and speeds, checking for leaks, and monitoring temperature and pressure. It's important to note that the specific manufacturing process can vary depending on the type and size of the marine engine, as well as the manufacturer's processes and technologies. Additionally, environmental regulations and sustainability considerations are increasingly influencing the design and manufacturing of marine engines. Diesel engine assembly is a complex process that involves the construction and integration of numerous components to create a functional and reliable engine. Ensuring the quality and reliability of a diesel engine is crucial for its performance and longevity. The quality of the components used in the engine is paramount. This includes the engine block, cylinder heads, pistons, crankshaft, camshaft, bearings, and other internal parts. Using high-quality materials and ensuring precise manufacturing tolerances are essential for longevity and performance. Diesel engines require very tight tolerances to operate efficiently and prevent problems like coil leaks or excessive wear. Proper measuring and machining processes are essential to ensure all components fit together precisely. Proper torque and tightening procedures are critical to prevent issues like leaks, overheating, or component damage. Bolts and fasteners must be tightened to manufacturer specifications to maintain the structural integrity of the engine. A well-designed and properly functioning lubrication system is essential to ensure that all engine components receive adequate oil to prevent friction and wear. Insufficient lubrication can lead to catastrophic engine failure. Maintaining proper engine temperature is crucial for preventing overheating and engine damage. Ensure the cooling system, including the radiator, water pump, and thermostat, is in good working condition. The fuel system should be assembled with care to ensure the proper delivery of diesel fuel to the engine. Any issues with fuel injection or delivery can lead to reduced performance and increased emissions. Precise timing of the engine's components, such as camshaft and injection pump timing, is essential for proper combustion and performance. Incorrect timing can result in poor fuel efficiency and increased emissions. Properly addressing these issues during diesel engine assembly is essential to ensure the engine's reliability, performance, and longevity. Manufacturing giant engines is an extremely complex process and requires a high level of technology, and so does its maintenance and overhaul. Diesel engine repair and maintenance encompass a range of essential tasks that ensure the optimal performance, longevity, and reliability of diesel engines. Understanding the specific requirements and best practices associated with diesel engine care is crucial for maximizing efficiency and minimizing costly breakdowns. In this part, we will delve into the key specifications of diesel engine repair and maintenance. the fuel is burned in the engine combustion chamber, a large number of harmful substances will be produced. Generally speaking, every 100 gallons of gasoline produces 1 to 5 pounds of nitrogen and sulfuric acid. These substances will not only cause corrosion to the cylinder, but also rush into the engine through the 3 piston rings, upper ring, middle ring, and lower ring, causing metal corrosion to the main components of the engine, such as cam and crankshaft. This corrosion cannot be eliminated only by the use of lubricating oil. After the engine is shut down, it will cool from high temperature to low temperature. This temperature change process will produce water-cooled condensate and even ponding in the engine. This will cause serious metal corrosion to the engine, especially when the engine is restarted in a short distance and the engine temperature is too late to evaporate water vapor. This kind of wear cannot be solved by lubricating oil. Overhauling giant pistons, such as those found in large engines or industrial machinery, is a complex and specialized task that requires expertise and the right equipment. Here is a general outline of the steps involved in overhauling giant pistons. Ensure that the equipment is safely shut down and disconnected from power sources. Use appropriate personal protective equipment, PPE, such as gloves, eye protection, and hearing protection. Begin by disassembling the piston and its associated components, including connecting rods and cylinder heads. Label and document the disassembly process to ensure correct reassembly. Thoroughly inspect the piston for wear, damage, and other issues. Check for cracks, scoring, or signs of overheating. Measure the piston diameter and check for ovality or taper. Clean all parts using appropriate cleaning solutions and methods. Remove carbon deposits, dirt, and old gaskets. Ensure that all surfaces are completely clean before reassembly. Replace any damaged or worn components, such as piston rings, wrist pins, and bearings. Use high-quality replacement parts to ensure proper function. If necessary, the piston and cylinder may require honing or machining to restore their dimensions and surface finish. Carefully reassemble the piston, connecting rods, and cylinder head according to the manufacturer's specifications. Torque fasteners to the specified values and use the correct assembly lubricants. Conduct a pressure test or leak down test to ensure that the piston and associated components are properly sealed and functioning. Ensure that the piston and connecting rod assembly is properly balanced to prevent vibration and excessive wear. Apply the appropriate lubrication to all moving parts, including the piston rings and wrist pins. Reinstallation. Reinstall the overhauled piston and components into the engine or machinery, following the manufacturer's guidelines. Testing and tuning. After reinstallation, start the engine or equipment and conduct performance tests. Make any necessary adjustments to optimize performance. Maintenance. Develop a regular maintenance schedule to ensure the longevity and reliability of the overhauled components. Keep in mind that overhauling giant pistons is a specialized task that often requires the expertise of trained professionals and specialized equipment. It's crucial to consult the manufacturer's documentation and guidelines specific to your equipment and engine type to ensure proper overhauling procedures are followed. Additionally, working with experienced technicians or engineers in this field is highly recommended to ensure the best results and the safety of the operation.
Hvor det er pakket.